This is Maggie Gundersen, and I'm the president and founder of Fairewinds Associates, and I'm really happy to welcome you here today. Today, as a change of pace, we have a special guest, and that is Marco Kaltofen. He is an expert in radiation chemistry and monitoring, and he is a professor at Worcester Polytechnic Institute in Worcester, Massachusetts. So he will give you a little bit about his background and introduce himself, but I just want to thank you, all of our viewers, for watching us so often and watching Arnie's videos. And we wanted to answer a lot of the questions that you've had. We've had hundreds of emails asking us about radiation. And as an expert witness and paralegal services firm, I'm a paralegal, and we have other experts who work with us in the firm. We wanted to bring you expert testimony from someone who knows more about radiation than we do. Arnie, as a nuclear engineer, knows what happens inside the reactor and how those actions create the issues that have happened at Fukushima and at other plants across the country. But now Marco will be able to talk to you about what happens when the radiation comes out and where it's going. Marco, thank you so much for joining us.
Thank you very much for having me. Actually, I'm working on a dissertation. I'm just an older grad student at Worcester Polytechnic Institute. And what my research is in is nuclear fallout and tracking it over long distances. One of the things that's very interesting about the Fukushima radiation releases is that we often hear about general radiation levels, things people measure by sticking a Geiger counter out a car window, for instance. What I'm looking at are microscopic or even nanoscale particles that contain highly radioactive materials that are small enough that they can just blow with the wind and sometimes travel great distances. In our research, we've been able to track some of these particles hundreds of miles, even thousands of miles. And what happens is, unlike the radiation we're seeing in Japan, where someone can just move, drive away from a high radiation zone, these particles travel globally, and if they're inhaled, if someone breathes them in, you actually carry that with you in your body. It has a very different impact, and it's the kind of radiation where background doesn't mean as much. It's more a matter of how do we avoid eating or breathing in those radioactive particles.
That's really interesting material for us to hear, and that answers a lot of the questions that we've been getting. How is this different than, say, dental x-rays?
Well, the thing about a dental x-ray is it's a set amount of radiation. We can predict better what is going to happen to someone who has that kind of dose, that amount of radioactivity. With a particle, it's very different. A single particle can carry a pretty significant amount of radiation. And wherever it lands in your body, it can start to damage that tissue or kill cells. Cells that actually survive that kind of irradiation could potentially form a tumor. So we worry about how these particles travel, whether they're traveling through the air and we breathe them in, or whether they get absorbed into our food and water. We should behave differently if we want to avoid that kind of radiation. And the thing about a particle, of course, is it travels a long distance, but it doesn't change very much. And now we're beginning to see some of these radioactive particles appearing in air in the United States that look very much like the particles we find in Japan. Our early data is showing that particles that contain americium, europium, bismuth, uranium, and other radioactive materials are found in the air and in the soil in Japan, and we're starting to see particles like that appearing on the west coast of the US in some of our other air samples.
So, if I understand correctly what you've said, for example, radiation from cigarettes, that would be something internal?
Correct. There's a certain amount of natural radiation in a cigarette. We take it into our lungs, and I think by now we all know that that's just one of the many reasons we get lung cancer from smoking.
What about we hear all the time, well, the radiation you're receiving is just like an airplane trip or a chest x-ray in that sense. Like, what's the difference? Can you explain that to us?
Of course, these are short-term exposures that we're comparing the radiation to. A plane trip is a few hours. A dental x-ray takes a few moments. Your exposure is over. The trouble with particles is we can get these particles into our homes where they're going to constantly recycle and continue to expose people. That radiation exposure doesn't end after a few moments or a few hours. It can be continuous. And if we do absorb it in our bodies, and then we're going to get that dose potentially for the rest of our lives. So it's very important to distinguish radiation caused by these particles in dust and take extra measures to reduce that exposure.
So people leaving the contaminated zone, for example, are still going to be getting these particles, these little pieces that we can't see when they breathe.
What's happening is these particles tend to stick to the nearest surface. They can stick to our clothing, to our skin, to concrete, even to things like carpeting or plant material. So if we want to reduce the exposure, we have to either prevent those particles from landing in the first place, or clean them off, or get rid of the affected clothing, or even the affected soil that has to be removed. Anything to reduce that long-term exposure to the radioactive particles.
So you found, your testing has found this, these little particles contaminated
When
in
we
just
I'm sorry.
in just Japan or all over?
We see some of the same things appearing in our samples in the United States. What we've done at Worcester Polytech is set up a half dozen air sampling stations. They're on the western U.S. coast, the East Coast, Hawaii, and Japan. And we look at some of the radioactive materials we see in Japan, like radioactive iodine, radioactive cesium, or these particles that contain americium and similar materials. And we see the same signature in our samples from the United States. There are less of them, but they're still there, and they're clearly related to the Fukushima release.
Wow, that's serious. What can you tell us more? What does that mean for us if that fine dust is escaping from Fukushima all over the northern hemisphere? Is it all over the world?
I would think that we'd be seeing more of it in the northern hemisphere. Back in the 1960s, when we did atmospheric nuclear testing, we tended to see the radiation landing in about the same latitude where the bombs were detonated. So if you detonated it in the northern hemisphere, you tended to find it in the northern hemisphere. The United States and North America, of course, is at about the same latitude as Japan. So we would expect to find more of their releases here in the U.S. And just as a rule of thumb here, the kinds of levels that we're talking about in Japan, nationwide, are probably a good deal larger than even the peak levels of the atomic test period back in the 1950s and 60s.
So what we have now coming from Fukushima is larger than the bomb testing from the 50s and 60s?
Well, the signal that they're getting in Japan certainly is. It remains to be seen how much of that radioactivity is going to come to the United States. Again, our concern is because it exists as a dust particle, it can actually land somewhere and continuously expose someone. It also means that because it's a physical thing, we actually have some chemistry that might help us deal with it. But there's going to be a lot more monitoring required as we try and figure out how big a problem this is going to be in the United States. Certainly we can detect it, and we can see that these particles are here, but we need to start looking at some of the things like sensitive food crops, the kinds of plant material that we know tend to collect radioactive particles and incorporate them into the plant. We need to start looking at that and find out how serious the problem really is going to be for us.
Where will people find that kind of information? Where can they look to say, see what they should eat, what they should grow, should they not? Is this going to, you said something earlier about in the soil, is this going to impact people who garden? I've received hundreds of questions about that.
It potentially could. There are some long-lived materials like cesium that stay radioactive for a long time. And cesium tends to do the same thing in soil that potassium does. I think a lot of gardeners are familiar with potassium-based fertilizers. Potash contains potassium. Cesium, even though it's radioactive, mimics that potassium. So it's going to behave the same way that the potassium does. That's a concern. That's going to take a consistent sampling effort to see how much of that is being incorporated into the food plants before they get into the market. We did something similar with the BP oil spill, where the FDA and independent agencies, including my institute, tested seafood, oysters, crabs, and found oil in those commercial products. We're going to have an even bigger effort now to look for radiation, because this is going to be a nationwide problem, not just limited to one region of the country.
But I read something about the EPA not testing fish, choosing not to test fish, and that some of the monitoring has been turned off. What do we do about that?
I haven't seen any data for fish or for agricultural products except milk at this point. We are detecting levels of radiation in milk because of the radioactive iodine that tends to accumulate in dairy products. I think what we need to do is expand what we're doing and look at crops that might be sensitive to picking up radiation from dusty fallout. And without the numbers, we're really not informed enough to make any decisions.
So what should people do at this point?
I think what people should do is remember that we have learned to try and deal with toxic dust for a long time. I think through public education, we've dramatically reduced exposures to lead in dust for children. It was a major public health issue, and we were able to take some corrective action and deal with the problem. We may need to, based on what our data tells us, do something of a similar scale and try and find those ways that we can protect the public health by reducing exposure to radioactive dusts. But the first step is going to be testing. Without the numbers, we really don't know how much we have to proceed, how much of this corrective action needs to be taken.
So in answer to our viewers and listeners, what should they be doing now? People have called me and I've said, contact your mayor, your governor, your state reps, and most importantly, your federal reps. Let's get the monitoring system back up and working and doing what it needs to do to protect us. Am I on target?
I think you're partly on target, but I'm also going to speak to people who might be in Japan or in an area where there is radioactive fallout that is accumulating. And there you're going to have to practice good dust hygiene. Some of the things are very simple. That might simply be making sure that you're washing your hands before you prepare food. None of this is going to sound like rocket science. We've dealt with this before with other issues. This is something that we can test for, and there are ways to remove radioactive dust from food if they've fallen out. If they've been absorbed by the plants, then it might be that we need to make sure those materials just don't make it into commerce.
Well, this is radioactive dust that we can all inhale, correct?
Yes, it is.
So what does that mean for people coming in and out of a house? That means leave your shoes at the door and, not drag your outer clothing all the way through the house. Am I correct?
Those are good answers. In our own laboratory, we have to take a lot of dust control measures, and it's true. Shoes and sneakers stay outside, overcoats stay outside in the hallway. You don't want to bring that dust into your home. About 70% of the dust inside the home is really just dirt particles from the area immediately around your house or apartment. So you can reduce the amount of dust that's coming into your home. And think about that before you undertake, say, a home renovation. We've seen this on a small scale before, where People who renovate homes near a source of radioactive dust from a particular plant or accident will have to take extra dust control measures so that they don't become exposed when they raise the dust due to doing work on your home.
Well, that makes sense. But what about, we're coming up on the summer months, both here and in Japan. What does that mean for people who want to run outside or do activities that are vacation activities?
You know, these are tough questions. Probably for most people, even in most of Japan, the health benefits of being outdoors and getting that exercise and having fresh foods will outweigh your radiation risks. One thing we did find out during the period where we did do nuclear testing above ground was that sometimes the weather will drop a relatively concentrated amount of fallout in a small area, often far distant from where the detonation took place. So again, there's going to have to be a certain amount of testing. Maybe we'll find ourselves having a radioactive pollution alert in the same way we might have an ozone alert in the hot days of the summer in a major city, where they say, if you're going to exercise, maybe you just shouldn't do it tomorrow morning.
Well, that makes sense. But we have to get, again, that brings us back to getting our officials, wherever that is, if that's in a prefecture in Japan or that's, you know, in a state in the U.S. or a province in Canada, we need to get our officials on board to help with this process.
It's true, because even if you happen to have a Geiger counter, just holding a Geiger counter out the window doesn't really work. It won't measure that dusty fallout. That usually takes more expensive equipment, and it's a harder thing to do. So yeah, we are looking at asking our government agencies to take on this burden. It's going to be serious, and we're going to want to get that information in a timely way.
Marco, thank you so much. I'm hoping that you'll come back again, because I think that this will generate even more questions and that you'll have more to share with us. Is there anything in closing that you really want to let our viewers know?
Well, we'll keep looking for these radioactive particulates and hopefully get this data out and published as quickly as possible. And thank you for having me on.
You're very welcome. Thank you for coming and for participating in this effort to let people know what's really happening in Fukushima. Thank you.